One fire ranger stationed at A, one fire ranger stationed at A reports smoke 30 kilometers away. Whoa, does it read better in yours? Yeah, I don't know what, here we got it. There's like some issues in mine. Okay, one fire ranger stationed at A reports smoke 30 kilometers away in a direction east 30 degrees. So, east 30 degrees north at B. A second station at C, due east of the first station, reports smoke 20 kilometers away. To the nearest tenth of a kilometer, find the distance between the two stations. So what we have here is we have to draw some sort of picture representing the situation. We've got a station at A, so we can start with A. And if we go east 30 degrees north, right, north, east, north, south, wow. North, south, east, west. The bearing of east 30 degrees north, we can draw a little cross section here, and we would go towards the east and then 30 degrees towards the north. That would be an angle like that. So we know the smoke at point B. Oh, we got to add some. We have smoke at point B, and we know that that is 30 kilometers away. A second station due east of the first station. So due east means that that second station is somewhere along here. We don't know where along there because we don't know how far away it is. But it reports the smoke to be 20 kilometers away. How far away are the two stations? Did we draw this diagram correct? I mean, it's not perfectly to scale, but does it look like a possibility? Does this look like a little bit shorter, the green line a little bit shorter than the black line? Okay. Can you see that you have the opportunity here for the sine law? That whenever you have an angle and its opposite side, and it's not a right angle triangle, it allows you to use the sine law. So if I wanted to solve for something, this 30 would go with this angle. What do I want to find? I want to find this length from A to C. So there's a couple things that we could do to find the same information. Okay? Those of you that are astute and like to look for things before they happen, okay? Sometimes people are like, ooh, I want to look for things before they happen. You might say to yourself, hey, based on the activity we did at the beginning of class, I have this situation here where, remember when this was 3 centimeters? And when the side opposite the angle was less than the adjacent side, then two triangles are possible. Can you see that we have that situation here? That we could recognize the possibility for two triangles being possible. It could also be, maybe this is too short that it's not even possible. This might also be the last thing we looked at when we had 1 centimeter and you couldn't draw any triangles. Maybe 20 centimeters or 20 kilometers isn't long enough. Maybe there's no triangle. So we don't know right now, but there's a possibility of two triangles. It's definitely not one. Well, I guess there's a possibility for one as well. If it's perfectly 90 degrees, there's a possibility for one. So what do we have to do? Okay, we have an idea that there might be two triangles. We can set up our sine law. The only thing we can solve for is x. So we go sine x equals sine x over 30 would equal sine of 30 degrees over 20. And we can get sine x by itself. Type that into our calculator. I think it equals 0.75 mental math. Can you do that mental math? How did I get 0.75? Which may or may not, it is right. Whew. It would have been scary if I said, hey, you can do this with mental math. How did I get this number? And it's not the right number. But it was the right number. How did I get, without my calculator, 0.75? What is sine of 30 degrees? That's one of your memorized values. It's 1/2. Half of 30 is 15. 15 on 20 reduces to 3 on 4. 3 on 4 is 3/4. 3/4 is 0.75. So there's the mental math way you could get that. But this would be a calculator question because you still need to find x. Now, this is a grade 11 question. At this point, you have to say, oh, according to my cast rule, and the sine law will always be positive here. Your sine law will always be, hey, you should look here and here, not here and not here for sine, because sine is positive in quadrants 1 and 2. And since we're going to get an answer here, we now know that there's two triangles that are possible. So I go to my calculator, I go, well, first of all, I'm going to draw my pictures, one in quadrant 1, one in quadrant 2, make a triangle back to the nearest x-axis, label my reference angle for x, label my actual angles for x, and I go sine inverse of 0.75. So I'll write it out. Sine of my reference angle would also be 0.75. So my reference angle is 48.6 degrees. Therefore, x, well, in quadrant 1 would also be 48.6 degrees. In quadrant 2, you would go 180 minus 48.6 degrees, 131.4. Okay. Once you get good at these, you would show this step. And then you could show this step, and then you could go directly to here, and if you wanted to not draw the triangles or show the cast rule, if you can do all of that in your head, perfect. But I don't think you're ready for that yet. Once you have a full understanding of what's going on, and you can go from, hey, I need to find my reference angle, and then I need to find both my answers, you don't have to draw the little triangles every time, if you can see that in your head, okay? But for right now, I found that if you're not understanding it completely, draw it out, because it'll help you get to that point where you understand. And then you can start doing it faster with. But the problem is, if you try to do it too fast early on, and you're just memorizing what to do instead of why it's happening, you're going to forget it for grade 12, and then grade 12 trig is going to be extra hard. So, what we have now is two possibilities for x. I'm going to go back to my original one. I'm going to write 48.6, and I'm going to write, what was the other one? 131.4. Can you see that they both work? Both of them would keep you under 180 degrees. So there are two triangles. And whenever you have two triangles, we're going to take the time to draw them both separately. Okay? So we had point A. We had 30 kilometers at an angle of 30 degrees to point B. Point B is where our smoke was. And if I draw the 20 kilometers on this side, then this angle is less than 90. This would be, I'll change the color there. Then we have the 48.6 degrees at point C. And triangle number 2, can you see that if this 20 kilometers swung back along this way, if it was on a pin right here and you could swing that arm, that it would hit over there, creating an angle that was obtuse or bigger than 90 degrees. Can you visualize that? Just like when we had our rulers with the 3 centimeters. You could draw two triangles. This one, the obtuse one, is sometimes a little awkward to draw because the angles get they get really close to each other. I had to label that green angle on the outside because my 30 was too big to begin. Maybe I should have done it a little neater. But now we have two triangles. We are still trying to find the distance between A and C. And can you see that there's two distances now? Either on triangle 1 or triangle 2. Okay? If I want to find this red question mark, should we use the letter X for it? Have we used the letter X in this question? Yeah, we used X already. What letter would you like to use? Oh, we could use little b because it's opposite of point B. That would be the proper, let's call this little b. If you want to solve for little b, you need to use the sine law. In order to use the sine law, we need the angle opposite of little b. But can you see that you can now figure that out? You have two angles, 30 and 48.6. This one, if I do 180 minus 30 minus 48.6, I get 101.4 degrees. And here, if I do 180 minus 30 minus 131.4, I get 18.6 degrees. Well, yesterday, I was making like mental math errors like crazy in my grade 10. Today I'm like, I feel on. Good. So, if I have that 101 or I have that 18.6, I can use the sine law to find b. I'm going to split my page up here so I can do work for the triangle on the left, and I can do work for the triangle on the right. All right. So for the triangle on the left, if I want to find b, well, b is going to be over sine of 101.4, because those ones go together, equals, and then I can use either these two or these two. I would probably use these two because they were given to me. I tried to write everything that was given to me in black, so I remembered that was original data. The green I solved for, so there's a little bit of error there with decimal places. The purple I solved for, it's going to have a little bit of error with decimal places. But I can now go that b over sine of 104, putting in the sides on top, so it will be 20 over sine of 30. Multiply both sides by sine of 101.4. I can type this all into my calculator all at once. So 20 sine 101.4 divided by sine of 30, which is a half, 39.2. And since this is a distance, we'll need to include our units. So I know solving this is 39.2 kilometers. Going to the second triangle, we can set up the same thing, that b over sine of 18.6 degrees would equal 20 over sine of 30. Again, I'm going to use those two that are opposite of each other that I knew from the beginning. Same thing, you can get b by itself by multiplying both sides by sine of 18.6. Type this into your calculator. And we get 12.6. Again, add our units. Does it make sense that that side B should be shorter than the other side B? It was a word problem, so word problems should end with a statement. Station C is either 39, are we supposed to round the nearest kilometer to the nearest tenth? Oh, we were on. Or 12.6 kilometers away. We have two possibilities. It's either 39.2 kilometers or 12.6 kilometers. Okay? So sometimes we're going to have two triangles. Sometimes we're going to have only one triangle. And sometimes we're not going to have any triangles at all. How do we tell? Well, I think if we, here, I'm going to just view so we can see everything that we did. Oh my goodness, that's way too small. There's a lot of work that went into this question. Okay? I'm going to zoom back out so you can actually see it. What we did at the beginning is we recognized we had the sine law because we had an angle on its opposite side and it wasn't a right angle triangle. So then we could solve for x. We had the 30, we could solve for its opposite side, which is x. When we solved for x, we used our cast rule and we came up with two possible answers 48.6 and 131.4. I hope that you recognize for sine, cos, and tangent, there's always going to be two answers between 0 and 360. There's two places where it's positive, two places where it's negative for every single ratio that we have. Other than 0 and 1s, those are ones in the graph, they're special, but for any other decimal, you should be able to find two solutions. When we looked at both of those solutions, 48 and 131.4, we realized that they both worked. Because even 131.4, even though it's big, it still didn't make it, once you add the 30, it adds up to 160, it's still under 180. So this one had two triangles. Once you realize you have two triangles, draw them separately. Because then you can make sure you keep your mind straight on, I'm solving this triangle, I'm solving this triangle. The question still wanted us to find from A to C, which we labeled as little b, but now you had to find little b on one triangle and also find little b on the other triangle. That involved the sine law again, and then you could solve. So what we're going to do next, as a warm-up for the next section, which we're going to start today, is I want you to draw me a triangle, non-right angle triangle, okay? And you have to give me 3 pieces of information where you could use the sine law. And then draw a triangle with 3 pieces of information where you can't use the sine law. You can use the scrap paper that you had at the beginning. So I want you to draw a triangle, and another triangle, label 3 pieces of information, and on this one, you're allowed to use the sine law. On this one, you're not allowed to use the sine law. If you're unsure, put 3 pieces of information, either angles or sides, on there and see if you could use your sine law. In other words, there must be something you can solve for using the sine law. If there's nothing you can solve for using the sine law, then you have the second. Okay. How did you do? Tell me some numbers for either one. Somebody, Theo, what did you get for one of them?
I accidentally made a right angle triangle, so I can't.
Okay. Do you have, just tell me any numbers.
Well, I had an angle of 30.
An angle of 30.
And then the side that's like on the same side. Like, not the opposite. Yeah, I got 10, and on the opposite side I had 5.
5. Perfect. This would be example of the sine law. Why is it the sine law? Because he has those 2 pieces of information that are opposite each other. And that means that he could use this 10 to find x. It allows you to find something. Okay? So in a sine law, you need 3 pieces of information, and then you can find a 4th piece of information, because the sine law is like 2 fractions equal to each other. There's 4 things that are possible to put in, then you could solve them. Did anybody find one that doesn't work? Where you don't have, you still have 3 pieces of information, but you never have, see, in order to use the sine law, the orange thing is important. You have to have an angle and its opposite side. Could you tell me 3 pieces of information where you do not, you still label 3 things, but you never have an angle and its opposite side? You could label 3 angles. 50. Wow. Wow. I still want black. Here we go. 50 degrees, 50 degrees, 80 degrees. You cannot use your sine law because you never have an angle and its opposite side. Other possibility. pieces of information where you don't have an angle and its opposite side. Very similar to the three angles. Three sides. So if this was 8, 7, and 10, you cannot solve for it. Could you give me an example where you have, okay? Yes, with an angle and side, so this one? Okay. Well, there's no hypotenuse and hypotenuse because it's not a 90-degree angle. But you're saying, like, if I had this as 6 and this is 7, okay, then that also could never be done with the sine law because you never have an angle connected with an opposite side. So this is the key to understanding the sine law. But it doesn't solve all of our triangles. 3 pieces of information is what you need to solve a triangle, except for this situation. Because if I have 3 angles, I could stretch it and make it bigger and smaller with those same 3 angles. Right? I can make it a similar triangle, 50, 50, 80, that's smaller. So you can never solve a triangle if you only have the 3 angles, because there would be infinite triangles, bigger and smaller, that you could make. But you can solve this one and this one, but we can't with our sine law. Guess what we're going to use? Yes, something from the cafeteria. Coleslaw. Cosine law. But it's called the coleslaw, which is not actually coleslaw that you would get like from Chicken Chef when you order chicken. Okay? So that is our next section, which is 6.5. I'll end this video here, and we will get introduced to the coleslaw.